Okay, class, welcome to day 2 of substitution. This is Mr. Henry. I am making you these videos because I am away today. I hope that you are here today and are ready to go with these lessons. If for some reason you haven't already done the homework for substitution day 1, I would recommend going back to that and getting a little bit practice before we move into day 2. I'm going to start right off the bat here with a question I want you to try and solve on your own first, similar to one we might have ended on at the end of the day on Friday last week. So you can expect that the answer to this question might not be as nice. All right, here we go. Solve the system of equations, and we have the two equations right here. So I would pause the video now and then try the question on your own first, and then you can hit play and watch me solve the question and double check that your answer is correct. Okay, right off the bat, looking at these two equations, I notice that none of them are rearranged to isolate for y or x, which means I'm going to have to do that for one of these equations by myself. I do see, though, that in the second equation, I have a coefficient of 1 on y. So I would start by rearranging that equation. Y is positive, so I can leave it on this side of the equation. And I'm left with y equals negative 5x plus 12. And I'm going to number my equations. So this first one was 1, and let's call the second one 2. So now that I have an equation isolated for y, I can sub that into equation 1. So I'll say sub 2 into 1. So once I do that, I'll end up with something like 3x minus 2 times negative 5x plus 12 equals 5. Then I am going to expand this using the distributive property. So I have 3x plus 10x minus 24 equals 5. Rearranging this and collecting like terms, I end up with 13x equals 29. And with x as a fraction as my answer here, I have 29 over 13. Then I need to sub that into one of the two equations. I'm going to sub that into equation 2, just because that's already rearranged for y, right? So plugging that in, I should be able to easily get y without having to do any rearranging. So sub x equals 29 over 13 into 2. I'm out of space here on my page, apparently. Then, doing that, I'll have y equals negative 5 times 29 over 13 plus 12. Negative 145 over 13. Can use my simple work that I would normally do when I'm adding fractions here, try and make a common denominator. So multiplying 12 by 13 and then putting that over a denominator of 13, I end up with 156 over 13, which if I add that, I have 11 over 13. So I found y and x. Since I am looking for a point of intersection, I should just state that my point of intersection is 29 over 13 and 11 over 13. Okay, so that one is similar to what we would have done on Friday. So is question 2. So try solving question 2 on your own first, and then check out the answer once you are done. Okay, neither of these equations are isolated for x or y. really you could isolate for any of the variables. I have decided that I want to isolate for x in the second one. Right, you would get the same answer if you chose x in the other equation or y in either of the two equations. I just chose 2 because it's a smaller number, and fractions over 2 aren't that complicated to deal with. So rearranging that, I end up with 2x equals 5 minus 6y. Divide everything by 2, I have x equals 5 over 2 minus 3y. I'm not sure why my pen keeps switching colors, but hopefully you can bear with me here. As I did last time, I'm going to number my equations. Call that one 1, we'll call this one 2, and sub 1 into 2. Okay, that will mean I will have 3 times 5 over 2 minus 3y minus 5y plus 4 equals 0. Like last time, I need to expand what's in the brackets here. So I'll have 15 over 2 minus 9y minus 5y plus 4 equals 0. Okay, and this 4 would be the same as 8 over 2. So adding my fractions here, I would end up with 23 over 2 minus 14y equals 0. So 14y equals 23 over 2. Scroll down a little here. And rearranging for y, I have y equals 23 over 28. All right, moving 14 to the bottom, it gets multiplied by 2. So I have 23 over 28. Then I need to find x. So I'm going to sub 23 over 28 into equation 2. So sub y equals 23 over 28 into 2. So then I am left with x equals 5 over 2 minus 3 times 23 over 28. If I multiply that, and then I also on this side try and make a common denominator, this will end up being 69 over 28. If I want to make a common denominator here of 28, I have to multiply both of those by 14. So I have 70 over 28. So 70 minus 69 is 1. So x equals 1 over 28. Which means my point of intersection is 1 and 28. And 23 over 28. So the first two questions we've done so far are really nothing new, just a little more difficult versions of ones we did on Friday. The next question I want you to look at, we're going to see something interesting happen, but it will start out with the same process that we just have been doing for the past two questions. So why don't you try this question first, and then see what happens, and when you get stuck at something that seems like it doesn't make sense, hit play, and we'll work through it together. Okay, so if you tried that question, you might have got stuck at a point like this. I rearranged this equation, subbed it into the second equation, but I had 8y minus 8y, which gives me 0y, right? 8 minus 8 is 0. And I had 0y equals negative 8. Okay, so think to yourself, is there a number that I can multiply by 0 and end up with negative 8? No, right? Any number times 0 is 0, right? So obviously there can't be an answer here. So this might be a case where there is no solution. Think back a couple days, we might have talked about something where there was no solution. If you're thinking about parallel lines, then you're right. Parallel lines don't have a solution because they never cross, right? Parallel lines will go on forever. Those are very bad parallel lines, but you get the idea. They go on forever and they never cross, right? So there is no solution. Just like in this case of this equation, 0y equals -8, there is no solution. To prove this to you guys a little differently, let's think if we rearranged both of these equations for y and looked at the slopes. Right, for this first one, I would have 4y equals x minus 8. Divide everything by 4, I have x over 4 minus 2. The other equation, if I rearrange that for y, I'll have 8y equals 2x minus 8. Divide everything by 8. Then I have y equals also x over 4 minus 1. Right, so they have the same slope, which means the lines are parallel. They have different y-intercepts, which means they are not the same line, but they're parallel lines, and parallel lines never cross, so that's why there is no solution here. Okay, let's look at a different example now. In this example, we're going to see something slightly different happen, but also going to run into a case where we might not be able to solve it. Just to give you guys a heads up there. I want you to try it again, just like you tried the last one by yourself. And then when you get stuck, hit play again, and we'll look at the solution together. Okay, pause it now. Okay, so here is my solution to this problem. I decided to rearrange the second equation for x. So in doing so, I ended up with -2/3 y plus 4. I called that equation 2 and decided to sub that into the first equation. That looked like this. And then once I expanded and simplified, I ended up with, and hopefully you got the same thing, 0y equals 0. Now, in the last question, we had 0y equals -8. And we reasoned that that meant there couldn't be any solution because no number times 0 is going to give me -8. So now think to yourself, what number times 0 could give me 0? And, well, I hope you know that any number times 0 is 0. So if I have something like this, 0y equals 0, that means I could put any value in here for y, and this equation would be satisfied. So what that means then is that I have an infinite amount of solutions. Now, we've seen a case before where we have infinite solutions to linear systems, and that's when the two lines are the same line, right? If I have two lines that lie in the same place, then they cross everywhere along the line, meaning there is an infinite amount of solutions to the equation. Now, you would expect that, and we don't have to do it to show, because hopefully we know that if I rearrange those two equations, I would have the same slope and the same y-intercept. Right, one line would lie on top of the other line, and so they would look like the same line. Right, those two lines would cross everywhere, meaning there would be an infinite amount of solutions. So I want to jump to another question now. The next one on your page here, let's look at it. What value of k gives a system with infinite solutions? So there's a couple different ways we could solve this, but I want to approach it the same way we've been approaching all these other equations. I'm going to take this first equation and rearrange it so that I have y equals something. So I'll have y equals 2x minus 1. Let's call this equation 1 and this equation 2, and then sub 2 into 1. Right, then I would have 4 times 2x minus 1 plus 4 equals kx. Now, if I'm talking about infinite solutions, then we know I should end up with something like 0y equals 0. So let's expand this. I have 8x minus 4 plus 4 equals kx. And so I'll have 8x minus kx equals 0. Right, and if I'm trying to end up with 0x equals 0, then in order to cancel out this 8x, then I'm going to have an 8x over here as well, meaning k will have to be 8. Right, so if I have k equals 8 here, and I put k equals 8 into this equation, then I would have 8x minus 8x, which would indeed be 0. Now, I mentioned there were a couple ways to solve this, so I'll show you a slightly different method. If I took these two equations and rearranged them so that I would have y equals mx plus b, let's see what I would have. I already did that for the first equation, so I have y equals 2x minus 1. And if I took my other equation and rearranged it, this one, then I would have 4y equals kx minus 4. Divide those by 4, y equals k over 4x minus 1. So we can see they have the same y-intercept, which would be perfect if I'm trying to have two lines that are in the same place. And I have to think now, what k value would give me the same slope here? So if I want these slopes to match, that means that 2 has to be equal to k over 4, meaning that k has to be equal to 8, right? Just like we previously saw. So if k equals 8, then both of these equations have the same slope, and since they also have the same y-intercept, then we'd have two lines with infinite solutions. Okay, let's move on to the next question here. Okay, question 3. Okay, question 3 is very similar to question 2, except now I'm looking for a value of k which gives a system that has no solution. So I'm going to take the same, I'm going to do the same two types of answers that I gave last time. I'm going to try one first where I attempt to do a substitution and figure out what values of k I need to make this work. I'm also going to look at how can I rearrange these and look what slopes I would need to make two lines that are parallel. So first I'm going to start by rearranging this equation here for x, because that would be the easier thing to do. So I'll have x equals 2y plus 2. Let's call this equation 1 and this equation 2, and then sub 2 into 1. That gives me k plus 2, y equals 3 times 2y plus 2 minus 4. Okay, I can expand these on both sides. Ky plus 2y equals 6y plus 6 minus 4. And then moving the 6 over to this side, I end up with negative 4. So I have ky minus 4y equals 2. Now, we know that in order to get something that has no solution, I need to have ky minus 4y equals 0y, which means that in this case, k has to be 4. Right? You can note here that there is a value on the other side of this equation of 2, which means that I'm not going to have an infinite amount of solutions. I'm going to have no solution. So k should be 4. Let's look at that in a different way, just like we did last time. If I take both of these equations and rearrange them, the first one, when I rearrange it, I have y equals a half x minus 1. If I rearrange the other one, I'm going to end up with k plus 2y. Let's just rewrite the whole thing over here. Rearranging, I get 3 over k plus 2 x minus 4 over k plus 2. 4 over k plus 2 will be my y-intercept. To find a scenario with no solutions, I don't really care about the y-intercept as long as it's not the same as the other equation. What I'm really trying to do is get the slopes to match here. So for the slopes to match, that means that 3 over k plus 2 has to be the same as a half. If I cross multiply here, then I have 6 equals k plus 2, which you can rearrange to see that k equals 4. All right, so two different ways to solve the very same question. What's important to note is that if I put 4 in here for k, then my y-intercept would be negative 4 over 6, or negative 2/3, which is not the same as negative 1. Right? If I had a y-intercept of negative 1 here, then I would have an infinite amount of solutions, not no solutions, which is kind of the opposite of what we would be trying to find. Okay, lastly, I want to look at a question here where I promise you there is a solution, but at the start, it looks like this scenario would be difficult to solve. I've got an equation here for a line that's got a fraction in it, and my other one is also in standard form. Let's fix a little typo here. This should obviously be an a, not an x. But think, how would I deal with this fraction? On Wednesday last week, we talked about solving equations and solving equations with fractions. And obviously, the first thing we would need to do here is get rid of this fraction. So to do that, I would multiply by my lowest common denominator, which in this case is 4 because it's the only denominator. So multiply all terms by 4. Which would leave me with, and I'll write it down here, a plus 8b equals 4. I can rearrange that so that I have a equals, and that'll be a equals 4 minus 8b. So let's call this equation equation 1, and the one I just made equation 2, and then I can sub 2 into 1. From here, the rest of the question should be pretty straightforward. The tricky part was dealing with this fraction, because if I were to try and sub something into an equation with a fraction, that would make things very, very difficult. A lot more difficult than if I just got rid of the fraction to start with. So I'm going to sub in my equation 2 into equation 1, which means I'll have 2 times 4 minus 8b plus 15b minus 11 equals 0. We can expand that. 11 equals 0. So we were left with negative I guess, equals, and if I move the numbers to the other side, I have 3, or b equals negative 3. The only question is only half over now. I need to find a. So sub b equals negative 3 into equation 2. So I'm left with a equals 4 minus 8 times negative 3, which is 4 plus 24, or 28. So my point of intersection, AB equals 28 and negative 3. So like I said earlier, this question wasn't too much more difficult than any of the ones we did on Friday. The only difference being that now we had a fraction, so we just had to get rid of that fraction. Once we got rid of the fraction, it was actually a pretty easy question to solve. So let's look at one last question. I'm not going to solve this one for you guys. I want you to see if you can figure it out yourself, and I'm going to leave it as a bit of a challenge. We'll maybe take this one up when I get back on Thursday, but I encourage you guys to try it, especially if you're comfortable with everything we've done so far. So that's the last question here. I don't believe I photocopied it in your handout because I wanted to just leave it as an extra question, but we've got now 3 equations, and I'm trying to find the values of A, B, and C that would make these 3 lines, or the 3 values of A, B, C that I would sub in to make these 3 lines cross. So you might find you have to sub one into another and then substitute that into something else. I encourage you to experiment and see what you can come up with and see if you can find a solution to this. That is the last question from today's lesson, so you guys can get started on the homework questions, which should be on the course schedule, which I photocopied for you guys, so hopefully you already have that. All right, let's get started on the homework, and I will talk to you guys tomorrow.